All right, here's the last one, Rain. They ask you to compare two different equations that look pretty similar. One by graphing them both, and two by looking at the table for both. So we just talked about this graph. This one has a slope of 2 and no y-intercept. Remember, no y-intercept means you're going to start at 0, 0. And here I'm going to go up 2 over 1 and up 2 over 1. And when I draw the graph, I look like that. Okay. If I do this one, the y-intercept is 1, so I'm going to start at 1, 0, 1, and I'm going to go up 2 over 1, up 2 over 1, and so on. All right, and the idea they really want you to see here is that they're actually very similar graphs. They look really almost exactly the same. The difference is where they cross the y-axis. So this one crosses at 0, this one crosses at 1. In fact, if you did them together, the first one would look like this. All right, so this is the first one, and this is the second one. They're actually parallel, right? They have the same slope, but one of them is shifted up 1. When you make a table, you just kind of plot some random values. I did -1, -2, -1, 0, 1, and 2. And I just plugged them all into this equation, and here's the numbers I got. And then I did the same thing for this one. I plugged in these 5 numbers. This can be kind of random, but usually, you know, those are some good numbers to start with. What they want you to notice here is that these are a set of numbers, and these are the same numbers, but just add 1, right? So -4, if you add 1, you get that. -2, you get that. 0, you get that. 2, add 1. And so all of these numbers are just 1 more than all of these numbers. And what that means is, on the graph, is that every single point is going to be moved up 1. So from going from graph number 1 to graph number 2, every single point is moved up 1. That's kind of the key idea here.